Lesson 8.4, Day 2, works with dividing rational expressions. Now, truth be told, when you divide fractions, you technically aren't doing a division. Hopefully you remember the keep, switch, flip rule. Steps to dividing rational expressions include these 5 things. The first thing, of course, is to factor the numerator and denominator completely. And just like in Day 1, we'll state restrictions in the domain. So x can't equal this, otherwise there also might be new variables like y and z. The big thing for this is step 3. We're going to do the keep, switch, flip rule right here. And when we do that, you may have additional restrictions to add to your domain. You always want to include that step 4 with your answers you already had in step 2. When you do the keep, switch, flip rule, what you're doing is changing the division to multiplication. And then it really becomes what we did in Day 1. Any numerator can cancel out with any denominator. And like in Day 1, we'll leave our answers in factored form. We just have 3 examples for this lesson. Let's get started with the first one. 5x squared y cubed divided by x to the 7th divided by 30x y to the 4th divided by y to the 3rd. This means we have a fraction divided by another fraction. In step 1, we're supposed to factor. But for this problem, there's no addition or subtraction that has factoring involved. For step 1, we leave everything pretty much the exact same. We're not changing the division just yet. That's step 3. All right, so in this form, notice we have 2 different denominators. Therefore, for step 2, we know that neither of the denominators can have a value that equals 0. If we say x to the 7th can't equal 0, that just means x can't equal 0. That's pretty easy. And if we say y to the 3rd can't equal 0, well, that means y can't equal 0 either. For this problem, the domain is pretty easy. Now watch what happens in step 3. Here's that keep, switch, flip rule. We're going to keep the first fraction, 5x squared y cubed, over x to the 7th. We're going to switch the dividing to multiply, and then we're going to flip the second fraction. That means I'm going to put y to the 3rd on top, and then the 30x y to the 4th on the bottom. Now, step 4 would have us stating any additional restrictions with that new denominator. But notice we have an x and a y. So we already know that the x can't equal 0 and the y can't equal 0. So there's nothing new to add for that step. So then step 5, we're going to look at taking any numerator and crossing it off with any denominator. But for problems like these, when there's no addition or subtraction, I like to actually take this and multiply it straight across, applying our property rules for exponents from chapter 5. If we have 5x squared y cubed times another y cubed, that would give us 5x squared y to the 6th. Remember, when you multiply like bases, you add the exponents. In the denominator, if we take x to the 7th times 30x y to the 4th, the 30 would just go out in front as your coefficient. If we have x to the 7th and technically x to the 1st, that would be x to the 8th. And then we have y to the 4th. Now, when we reduce this fraction, the 5 goes into 30 6 times. So we can reduce that part. We have x squared over x to the 8th. So that would give us 2 minus 8, which is x to the negative 6th. Y to the 6th over y to the 4th would be y squared if we subtract those. So then on the bottom, we would just have that 6. Now, anytime we have a negative exponent, hopefully we remembered this rule. A negative exponent means we take the reciprocal of the base, which ultimately then is just going to put that in the denominator with the 6. So the y squared will stay in the numerator, the 6 is in the denominator, and we're going to drop that x down to the bottom, and that makes your exponent positive. That is the simplified answer in fraction form. For this next example, I'd like you to cross off x squared minus 6x minus 15, and please rewrite it as x squared minus 8x plus 15. For whatever reason, I think I mistyped it when I made the note packet, and then I didn't see it until after they were printed. So let's put it in that form. We have x squared minus 8x plus 15 over 2x squared plus 2x divided by x squared minus 14x plus 45 all over x squared. Now, in step 1, we're going to factor. If we have x squared minus 8x plus 15, numbers that multiply to get 15 but add to get negative 8 would be negative 5 and negative 3. In the denominator, 2x squared plus 2x, notice there aren't 3 terms, so we'd have to look for a common factor. We could take a 2 and an x out of both terms. But be careful here. If we take 2x out of 2x squared, we'll have x left over. And if we take 2x out of itself, we need that placeholder. That would be just adding 1, because 2x goes into itself one time. All right, let's try the next fraction, divided by x squared minus 14x plus 45, two numbers that multiply to get 45, but combine to get negative 14 are x minus 5 and x minus 9. And then x squared doesn't factor because there's no addition or subtraction. There's step 1. In step 2, we'll state restrictions on our domain. For our first fraction, we have 2x can't equal 0, and x plus 1 can't equal 0. So in this case, x can't equal 0, and x, if we move the 1 over, x also can't equal negative 1. So let's underline those. And for that second one, if x squared can't equal 0, well, that just means x can't equal 0, and we already have that, so that one's already covered. We don't have to write 0 twice. Okay, now step 3. This is that keep, switch, flip step. Again, we're going to keep that first fraction, x minus 5, over x, or times x minus 3 over 2x times x plus 1. We're going to switch the divide to multiply, and then we flip that second fraction, x squared on top, and then x minus 5 and x minus 9. Now, going back to step 4, recognize that we have new denominators that will actually add this time to the originals. If we're adding some on, I'm going to list the ones we currently have. X can't equal 0, and x can't equal negative 1. And if we set x minus 5 can't equal to 0, or not equal to 0, wow, sorry. X minus 5 doesn't equal 0, we'd add 5. So x also cannot equal positive 5. And then the same thing with x minus 9. Add that to move it over. And x can't equal positive 9 as well. We have 1, 2, 3, 4 total restrictions in this problem. I'm going to move step 5 over here just so that I have enough room. If we have x minus 5 times x minus 3 over 2x times x plus 1 times x squared over x minus 5 and x minus 9. Remember, things can cancel on top and bottom if they're an exact match. I see right away that I have an x minus 5 and an x minus 5, but I don't have a match with x minus 3. Over on the right, I have x squared, so technically we could take this x out of the bottom and cancel it with one of the x's on that top. So there's still an x left over. This would mean this plain x, I'm just going to write that out in front of the parenthesis, and I'm not going to multiply it in. We'll just leave it like so. And then on the bottom, we've got that coefficient of 2. We have x plus 1 and x minus 9. So this product is our final answer for this question. For our last example, we have x squared minus 2x minus 15 over x squared y minus 25y divided by, oh, here we go, x cubed plus 27 over x squared plus 5x. All right, in that first fraction on the top, two numbers that multiply to get negative 15 and also add to get negative 2, we can do x minus 5. Oops, there's a, wow, that minus won't go in there. Hang on. Whoops, now I'm highlighting it. All right, sorry. We'll start over. There we go. Okay, so when we factor x minus 5 and x plus 3, now we're set. Now watch this in the denominator, everybody. We have x squared y minus 25y. Notice both of the terms have a y in common. We can factor that out as a common factor, but it doesn't go away. It just stays on the outside. And then we have x squared minus 25 left over. And those are both perfect squares. So from 8.0, that's called the difference of perfect squares. And that will separate. The x's, or the x squareds, break up into x and x. 25 breaks up into 5 and 5. And there's a plus and a minus in between them. And then let's go ahead and put that y out in front. Oh, okay. Divided by x cubed plus 27. So that's the sum of two cubes. And we have a formula for that, which you will be responsible for knowing. If it's x cubed, 27 is the same as 3 cubed. So that's a cubed, sorry. There we go. So that's a little parenthesis and then a big parenthesis. X cubed plus 3 cubed would be x plus 3 for the first parenthesis. And then x squared minus their product plus 3 squared, which is 9. And then in the denominator here, we have x squared plus 5x. We're missing that last term. All we really have here is a common factor of x, and then x plus 5 is left over. That's step 1. Okay. Step 2. Let's state our restrictions for any variables in the denominator. In the first fraction, y can't equal 0. Easy enough. X plus 5 can't equal 0. And x minus 5 can't equal 0. Solve for x. Oops, I almost put a plus in there. We don't want to change the sign as we move it over. X can't equal negative 5. And then if we add 5 for this one at least, x can't equal positive 5. So there's this restriction, this one, and this one. In that second fraction, we have a plain x on the outside. That one can't equal 0. And then we have x plus 5, but we've already done that one, so we don't have to state the restriction again. All right, step 3, keep, switch, and flip. We'll take that first fraction and we'll keep it as is. X minus 5 times x plus 3. And then in the denominator, y times x plus 5 times x minus 5. Switch, divide to multiply, flip that second fraction. X and x plus 5 go in the numerator. X plus 3 and x squared minus 3x plus 9 go in the denominator. I'm going to need more room here. Slide that up. Oh boy, we'll try to get that to fit. Now that we've switched that denominator, we're going to check for additional restrictions. We have that x plus 3, so let's first start off by listing the current ones. Y can't equal 0. X can't equal negative 5 or positive 5. And x also can't equal 0. When we add that new one, x plus 3 can't equal 0. Move the 3 over, and x can't equal negative 3. There are a lot of restrictions for this solution. Now that x squared minus 3x plus 9 is going to give you an imaginary solution. That's why remember it's not ever factorable. So we can leave that one as is. We don't have to find imaginary solutions for our domain restrictions. All right, so speaking of domain and finding our final answer, let's go to step 5. I'm going to slide this over to the right a little bit. I hope you have some room to write this. For step 5, let's just take everything in the numerator, x plus 3, whoops, and then x minus 5. I just rewrote them, sorry, and switched the order around. And then we have y, x plus 5, x minus 5, times, and then that second one, we have x times x minus 5, or plus 5, over x plus 3 for the small parenthesis, and then x squared minus 3x plus 9 for that big parenthesis. Okay, let's cross some things off. That's more fun. Now I see the x plus 3 on the top crosses off with the x plus 3 on the bottom. X minus 5 matches on top and bottom in that same fraction, and that's okay. There's our plain x, which doesn't cancel, but the x plus 5 will cancel out with the x plus 5 in the denominator here, leaving us for a final, or with a final answer of x in the numerator over y times x squared minus 3x plus 9. And there you have it, dividing fractions with polynomials.